Okay, guys, so right now we're presenting my project, which is dark web crawlers. So, the purpose and the motivation to this project. My purpose for doing this project was that I wanted to understand how crawlers collect and analyze dark web data. I also wanted to explain how investigators map hidden networks, review ethical and legal considerations in the dark web. Uh, my motivation was the increased cybercrime and anonymous marketplaces in the dark web. And also because since I want to work in cybersecurity, I think like the dark web and these crawlers are like they would play a really big part in my job in the future. So how do crawlers work? Crawlers work firstly by accessing the dark web. They start from a city URL, then they fetch pages automatically, and they extract links and data. They do this by following links, which they they basically open a page, they go into a link, and sometimes that link has other links that they follow into. Then the crawlers extract that data and they store it and organize it in a way that investigators can look at it and they can analyze it. And this is what turns just the raw crawling into actual intelligence when you analyze all the information. And finally, there's also a really big role in crawling that is the legal and ethical safeguards, which is basically that crawlers must avoid interacting with illegal content. Like they can't purchase illegal things or download sensitive data or sensitive things that would be illegal. So there's two types of crawlers. The first one is breadth depth, and the second one is depth first crawling, which is normally abbreviated by BFS and DFS. The main difference is that BFS starts with a seed, and they visit all the pages linked from that page, and then it moves to the next layer. On the other hand, DFS follows a single link and it explores that link completely. Some of the strengths of BFS is that they're great for mapping, for building a full map of a hidden service. And on the other hand, DFS is useful for exploring threads that are deep and they have a lot of like pages like vendor threads and stuff like that. A weakness that DFS has is that you can get stuck in a long thread since its purpose is to just analyze the thread completely. And if the thread is long, you can get stuck in it. And a weakness that BFS has is that it can be slow on the dark web. Like Tor can take a long time. What do crawlers actually do? Crawlers move through websites automatically and they pull info as they go. Kind of like a bot, they never get tired or distracted. And even though this idea is pretty simple on paper, crawlers basically keep the entire internet running behind the scenes. Actually, Google is a crawler basically. Search engines. Like I said, Google is not a crawler, but it depends on crawlers. Moreover, cybersecurity teams use specialized crawlers to scan massive amounts of pages way faster than any human could. Crawlers help also spot sketchy websites, weird domain patterns, leaked data, and suspicious activity. Pretty much anytime you look up something in the web or analyze anything online, there's a crawler working that made that possible. Think about that every time you search up something in Google. So, now moving on to the dark web. Why is crawling on the dark web so hard? So, the main thing that makes crawling on the dark web hard is that the Tor network is normally slow and unpredictable. These pages can load extremely late and disappear randomly, or completely switch to a completely different onion address overnight. Moreover, these hidden services are designed to stay private. A lot of them require credentials to log in, some of them are invite only, or they use a lot of security layers, which could trick crawlers and basically throw the crawlers up because they break the normal crawling patterns so bots can map the site structure. Also, with dark web crawling, you have to create special kind of crawlers that completely imitate real human behavior so you don't get flagged or banned from the site that you're investigating. And even with human pattern, some sites can throttle requests or shut down completely once they sense scrapping. So, what are some of the technical obstacles in dark web crawling? Dark web sites are super unstable. Servers go down randomly, and admins move onion addresses. And some pages just vanish without a warning. URLs can also rotate often, sometimes daily, making it hard for crawlers to keep track of where anything is in the web. Moreover, Tor's high latency means that one page can take forever to load, so crawling that would normally take minutes on the regular web could take days or a lot of hours. Moreover, because of all of this, researchers usually have built custom crawlers, as I previously said, that can handle these low speeds, weird HTML structures, broken links, and pages that purposely try to attack bots by seeing their differences with what a human would do. Moreover, how is this project linked to cybersecurity? Crawlers are used in cybersecurity by helping us track leaked data dumps, exposed passwords, and stolen credentials that show up on forums or hidden marketplaces, things that a human would never find fast enough. They monitor criminal markets, forums, and communication patterns to spot trends like new malware kits, scam methods, or sudden spikes in illegal activity. Crawlers can also map out clusters of accounts, wallets, or profiles that are connected, even when criminals try to hide behind different usernames. Security teams also use automated crawling to stay out of threats, instead, manually searching crawlers to scan massive portions of the internet for indicators of compromises. Some crawlers are also built specifically to look for mentions of company names, employee emails, leak credentials, or anything that could turn into a cybersecurity breach. So, what has our research shown? Crawlers can map out relationships between sellers, forums, marketplaces, and service providers, basically showing who interacts with who, even when everyone's trying to stay anonymous. Text patterns analysis help us uncover behavior trends, new scam techniques, and emerging threats long before they hit the first surface web. Many studies show that dark web communities have predictable patterns despite trying to appear chaotic, which helps researchers detect coordinated activity. A big chunk of academic work is focused on safety ethics, how to study dark web data without breaking laws and exposing illegal content or collecting more than necessary, which was something that when we were doing our own research on using crawlers, it was a little bit hard not stumbling across certain illegal contents in the web. Overall, the research emphasizes caution, privacy protection, and making sure crawling methods do not harm servers, expose sensitive info, or break regulations. Why do crawlers matter for investigations? Manual searching the dark web is basically impossible. There's way too much data, way too many sites, and pages move or disappear before you could even find them. So, automated crawling gives investigators a full and organized picture of what's going across the web, even the dark web, instead of just having random screenshots and isolated pages. Moreover, they connect the dots between different incidents by showing patterns in domains, usernames, posts, or even the writing style. This kind of automated investigation is now a core cybersecurity skill that companies expect analysts to understand how to use this automated data because it saves them times, it reduces blind spots, and it catches things humans wouldn't be able to see. So, what were my key takeaways? What I learned is that crawlers basically power everything online behind the scenes: search engines, cybersecurity tools, digital forensic systems, threat intelligence platforms, all of it. Even on the dark web, where everything's slower, hidden, and unstable, crawlers still play a huge role in helping investigators understand what's going on. Learning how crawlers collect, organize, and analyze data helps you understand how real investigators catch patterns, map criminal activity, and find leaks. After working in this project, I realized that automated data gathering is one of the most important skills in cybersecurity, especially if you want to deal with threat intelligence or digital forensics. This project helped me understand not only what crawlers do, but why people rely on them so heavily, and it made me more interested in the cybersecurity side of large scale data analysis. So, finally, I think that the project highlights and key outcomes were that I gained a stronger understanding of dark web structures and how crawlers navigate these hidden services. And I also developed a clear insight into the ethical and legal limits of dark web investigations, as well as learning multiple crawling methods and improving my research skills. And I think some of the key outcomes were the stronger understanding of how important data collection is and mapping this data collection, as well as having a clear explanation of how crawlers work and how they function and how they support cybercrime and forensic investigations. So yeah, this is my presentation.